Hello, everybody. I promised you tectonic anomalies. I know I have been MIA for quite some time. I am currently trying to do field work for a new book coming up. That's why you see all these here. It's been unseasonably warm, and the trees haven't been changing color, which is something I really wanted. But anyway, all besides the point. What we are going to do here is we are going to talk about plate tectonic anomalies, if you will, using Google Earth. Now, I did an intro, to this a while ago, saying I was going to do this, and I was going to pick certain things, and I'm going to do that, but I'm not going to pick like 30 things at a time. First, I just want to mention the vast majority of people, when they hear plate tectonics, they think of continental drift. They think of the continents moving about the globe. They have no idea that there's actual plates involved. That's why it's called plate tectonics. And that's fine. Generally speaking, from basic level, that's fine. The continents do move about the globe. It's not like they just float around the ocean floor or float upon the mantle. That's not what happens. Each continent or each landmass is connected to a plate, which moves due to spreading areas like the Mid-Atlantic Ridge here. And then in other areas, you get subduction where ocean crust is recycled. Now, the continental crust, which is most of the continents, not all land above water is continental crust, but we're going to keep the language simple here, okay? I want more people to know this. The continental crust is what we call mostly felsic in composition, meaning it's very rich in silicas, very simple silicas. Those main type of rocks, all the rocks are derived from are granites, what we call felsic rocks, light-colored rocks with lots of silica in them. The ocean plates are different. Mostly, not everywhere, but it talks for other times, it's composed of what we call mafic crust. And this is iron and magnesium-rich igneous rocks. Right? There's virtually no real sedimentary rock on the ocean floor. Now, yes, there are sediments, and yes, we do offshore drilling and stuff like that, but not like on the continents. And you see here, these little light areas on Google Earth around the continents, those are part of the continents. That is the continental shelf. Okay, that's something else you need to understand too. Okay, so we have the mafic ocean crust, which gets subducted as new ocean crust is being created, and that pushes the continents along. There are three basic mechanisms for plate tectonics. In the order of importance, or which ones dominate, from the most dominant to least dominant, you'll get different answers from different people. It is not magma convection, as most people think it is. Magma convection in the mantle just isn't quite powerful enough on its own to move plates around the globe. I know you've all seen drawings in textbooks and stuff of these big churning convection cells in the mantle, as if the mantle's some boiling water or something pushing the plates along. Now, the mantle does convect. That is true. But the mantle is a solid. It's a very plastic solid. It's not rigid at all, but it's still a solid. All right? And we have convection cells under large plates like the Pacific plate here, which is the largest single plate on the planet. And the second largest single plate, surprising to most people, is not the Eurasian plate, it's the North American plate. Because remember, plates include continents and ocean crust. All right? Now, I'm going to show you other videos too as we do this, but for now I'm just going to stick with Google Earth. I will show you later videos that will show you the relative age of the ocean crust, but it won't show you the continents. Why? Because the continents are much older than the ocean crust. The oldest ocean crust we have is in here. This used to be part of a much larger ocean, but this is a subduction area. the ocean crust is getting recycled. Over here, we're not exactly sure the age, but it could be 300 million years, maybe 4. As we're here, it's 0. Okay? So ocean crust is much younger because the oldest rocks on the Earth confirmed are not here. I've talked about this before. The Jack Hill zircons, or what we call detrital zircons, they are in sediment from older rocks that no longer exist. We don't know where they are, if they're even still around. It's up here in the Northwest Territories, as of right now, confirmed that everybody agrees on, and those are 3.8 billion years old. So 3,800 million as opposed to maybe 400 million over here. So as you can see, the continents are far older. That's because they don't get recycled. Anything that forms on the continents, any new igneous rocks that come up or sediments stay. They don't get recycled. Okay, so that should hopefully give you a decent introduction of what I'm going to talk about. And I want to get into these anomalies here. So basically, from a continental standpoint, we have several continents. We have North America, South America. This is from, just continents as they pertain to part of the moving mechanism of plate tectonics. Okay, Antarctica, we have Africa, we have Eurasia, we have Australia. This stuff is a mix of continental crust and non-continental crust. We'll talk about that hopefully sometime. And actually, Greenland. I know most people consider Greenland an island, but there's enough tectonically going on, and it has what we call cratons. At the core of every continent is a very old craton during the Archean or at the latest Paleoproterozoic, but the oldest ones are Archean. Every continental mass has an Archean craton. Craton is just a block of land that is old and the rest of the continent formed around. North America was not always this big. It's grown over time. But we won't get into that here. Those are talks for other times, but I'll kind of allude to it as I do this series. But Greenland has cratons. North America does, South America, Antarctica, Australia, Africa, Eurasia do. Okay? There are no cratons in Madagascar. I don't think. No, there might be, but it doesn't fit the definition of a continent. There's no cratons here. And this is one of the things I have with Zealandia. I don't know how many of you have heard of that. Somebody, 10 years ago or so decided, there's some crust down here that shows some topography and some felsic, continental style crust, even though it doesn't look anything like a continent. It has no cratonic material, but we want to get noticed, so we're going to call it a continent, and we're going to call it Zealandia. Okay, this Zealandia is not a continent. It doesn't fit anyone's real conception of a continent. New Zealand has no craton. There's no craton in any of this. Okay, so that right there tells you it's not continents. Okay, and it could probably get subducted. There is felsic crust elsewhere in the ocean. It's rare, but the Pacific plate itself, the largest one, has the most. And that's because the Pacific plate is generally older, not everywhere, but its size is unstable. So you're going to get felsic upwellings from time to time, like granites coming up through the mantle, and things as such as a response to subduction. Because like I said, this thing is old, it's not stable, and it's probably going to split into smaller plates at some point in the future. I'll talk about that too. But anyway, I just wanted to give you guys some background, and I will be using Google Earth features. I'm going to end this episode, record another one for you where we're going to first focus on this area here. All right? If you have any questions or comments, please leave them below, and I hope you guys learned something.